back modular exponentiation. To find b to the power n mod m efficiently, we use the following approach. Take your exponent n, write it in base 2. Okay? Then b to the power n will be a sub k minus 1. So it's the base, the base 2 expression we are using here. Alright. Note that each of these coefficients are either 0 or 1. So you're essentially calculating b to the 2 to the j, 2 to the j whenever aj is 1. Whenever aj is 0, that doesn't show up in your description. So now you're going to calculate the 2 to the jth power of b and find its remainder modulo m and then multiply them. Again, find the product's remainder modulo m. So let's first calculate 3 to the 14 and then calculate 3 to the 14 modulo 7. 14 is in binary digit description, it is 1110. So 14 is nothing but this is the binary expansion. So 3 to the 14 is 3 to the this plus this plus this and a 0. So that 0 doesn't need to be written. 3 to the 0 is 1. 1 to the power 1 is 1. So that 0 becomes immaterial. Only the non-zero coefficients contribute. 3 to the first power is 3. So that is 3 to the 14. You can calculate this easily, right? So 3 to the second power is 9. 3 to the fourth power is 3 to the second power. So that is previous numbers square, 81. 3 to the eighth power is 3 to the fourth power, its second power. So the previous numbers square. Okay, 6561. I don't know why I wrote this here. All right. Next, so what is 3 to the 14? It is 8th power, 4th power, 2nd power, all multiplied. 8th power, 4th power, 2nd power, all multiplied. And you get your number. Now, if I want to find modulo 7, what do? I go through each piece. Second power is 9. Modulo 7 is 2. So keep that in mind. Fourth power is again 9 times 9. Each 9 modulo 7 is a 2. So 2 times 2, 4 modulo 7. Eighth power is fourth power written twice, multiplied twice. Each fourth power is 4. You see? So 16 modulo 2. 16 modulo 2 eventually is 2 modulo 2. So their product, right? Eighth power we just saw was 2. Fourth power was 4. Second power was 2. Multiply it all out, 16, which is essentially 2 modulo 2. So you see, I didn't need to calculate all this to simply calculate 3 to the 14th power. Similarly, you can work with 3 to the 534 modulo 213. Well, first convert 534 to binary digit. So we have our procedure. You divide by 2, find the quotient, find the remainder. That remainder is your right-handmost digit. Your quotient is now the new dividend. Divide it, find remainder. Successively keep finding remainders until your quotient is 0. So you have these remainders. So 534 is 2 to. So these are the coefficients for the respective powers. Notice a whole bunch of zeros are thrown away. Only ones contribute to a power. So 3 to the power 534 is 3 to this power, 3 to this power, 3 to this power 4 and this power. All right. One at a time. Let's calculate 3 to the 6th power. Well, 3 to the 5th power is 243. Modulo 213 is 30. So 6th power is 3 times 243. 3 times 30, that's 90, modulo 213. So now all we are doing is calculating carefully. 3 to the 2 to the 4th power. 2 to the 4 is 16. So I know what 3 to the 5th power looks like. So 16 can be written as 5, 5, 5 and a 1. Correct? So 3 to the 5th power, 3 to the 5th power, 3 to the 5th power and 3 to the 1st power. But modulo 213, you already know it's 30, 30, 30 and a 3. So I'm going through this systematically. This is 90. This is 30 times 30. I will take a 10 from here, make it 900. Take the 3 here, that makes it 90. Why did I do that? Well, I can, go through. I'm working without calculator and that's the goal, to be able to do this by hand. So 900 modulo 13 I can calculate. So 213 times 4, you know how far it goes, right? It's 800 and something. 852. So is it 52? 26, 52. That's correct. 852. Whatever is left is 48. Aha, so that 900 got reduced to 48 modulo 213. So I take a 10 from here, make it 480. 480, again 213 times 2 is 426. So 54 left. So that reduces to 54 modulo 213. Now 9 times 54 you can multiply by hand. You get 486. 486. 213 times 2, remainder is 60. So modulo 213, it's 60. So you see, 3 to the 2 to the 4th power, we did entirely by hand. We didn't have to calculate the entire power. Likewise, so you got 3 to the 6th power here. You got 3 to the 2 to the 4th. Now we will work on 3 to the 2 to the 9th. 2 to the 9th is nothing but 2 to the 4th, 2 to the 4th and 2. So I will take 3 to 2 to the 4th first and take its power. Why did I do that? Because that we already calculated was 60. So 60 to the 2 to the 5th power. 60 modulo 213 doesn't do much. So I will take 60 times 60, that is 60 squared. So I take one of the power away and write 60 times 60. When I took one of the power away, I have 2 to the 4 left. 60 times 60 is 3600. Let's look at 3600. Multiply 230. So you're basically dividing and seeing how much goes in it. 213 times 16 takes you some distance and this is the leftover. So modulo 213, 3600 is 192 to the 16th power. So I take one of it away. That is, I take 16 is 2 times 8. So I take 192 times 192 to the 8th power, right? I take 2 away from here. That takes me 384 times 96. Notice I'm not multiplying everything. I just took away 2 from here. A factor of 2 multiplied here, that gave me 384 and this reduced to 96. 384 modulo 213 is 171. Take another 2 away from here, 342. 48 left over. 342 modulo 213 is 129. Take another 2 from here. 358 modulo 213 is 145, 24 left over. I take 4 away from here. I could have taken 2. I was a bit ambitious. Took 4, 580. So 580 is 254 modulo modulo 230. 154 times 6 is 924. 924 is 213 times 4 plus 72. So all that is 72 modulo 213. So remember the power 8 that continues. So I take 2 from here. 8 is 2 times 4, so that's power 4. 72 times 72. Okay, 72 times 72. So again, I'm systematically working through it. 72 times 72. Take 4 away. 72 times 4 is 288, which is 75 modulo 8, modulo 213. 75 times 18. 75 times 18 is 1350, which brings me back remainder of 72. So you see, I started 72 power 8. I got back to 72 power 4. Well, same procedure. Take 72 times 72, take power 2. But we just calculated 72 times 72. Modulo 213 gives me 72. Again, 72 power 2 is 72 times 72. Again, go through the same procedure. You get 72. Therefore, 3 to the 534 is this expression, if you remember. This got me 72, this got me 60. These two together got me 90. Well, multiply, so you have 0, 0, 0. This is 5400. 1140. So you see, multiply this modulo 213 is 81. So I shouldn't, there should be a 10. Okay. So let's go through the same procedure. Get the 9 in here, get the 10. And get the 10. 1566 is 750 modulo 213. So I don't know, 750 modulo 213. You can take 213 times 4 is too much, 3. What is 213 times 3? It is 639. So 750 minus 639 equals 111. That's it. So finally, we were able to answer this question. All right. So modular. So here is the same thing that we did. For each AI being the coefficients, x is x times power. So you're increasing the power of x, right? You want to find power. Power is previous powers multiplied. Keep going. All right. So this completes our lesson 13. We'll continue our video in our next next lesson in our next video. Until then, bye.